Hello friends, in this video we'll be looking at how longitudinal waves are produced. There's a spring and if the movement of hand will create a longitudinal wave. So just see that there will be a compression followed by a rarefaction which is developed by the movement of this hand. Okay. Have you noticed? In this video, a speaker is producing a sound. The frequency with which speaker vibrate or this membrane of speaker vibrate is the frequency of the sound produced. As the speaker moves forward and backward, it creates alternative compression and rarefaction zone. You can look at that. In this video, these are the dots represent the location of mean position of these particles. That this is the location of mean position of yellow, this is the location of mean position of this, and green, and similarly. And these are the actual positions of the particles. They are displaced from mean position. For example, the red is on the left side of its mean and yellow is very near to its mean. So by these movements, rarefaction and compression zones are formed. For example, this is a rarefaction zone and this green, close to green, is a compression zone. So you can look at that, how it is transferred as they are moving. I'm going to pause and let you know an important fact that at the location where displacement is zero, blue is at its mean position, there's a maximum compression or the particles are very close to each other, as well as where again the displacement is zero, we have minimum compression, or we can say minimum pressure or rarefaction. So when y is 0, we get maximum pressure as well as minimum pressure. So displacement wave and pressure wave have a phase difference of pi by 2. This is an important observation which we can see from this video. In this video, we'll be talking about how pulses collide or how pulses interfere or waves interfere. These are the two strings, 1 and 2. There will be two waves moving in opposite direction, and they will be, one will be up the string and another will be down the string, and when they will come at the same location they will superimpose. In reality there's just one string, one wave is coming from this side towards right and another is moving towards left. When they superimpose on each other, what is the resultant observation will show in this video. So look at this, these are the two waves, 1 and 2. This is the one string on which we have superimposed it. As they comes above each other, they will try to cancel each other, because according to this pulse the string should move up and according to this the string should move down. So at these 2 points they are cancelling each other and the point is not moving anywhere. Just look at even more observation. Now these points are above each other and they try to cancel each other. At this point displacement of lower string is less than the displacement of higher string, so somewhat string will have a shape somewhat in upward direction. Okay, go through this video once again, let's see. Okay, in this video we will be looking at two pulses which are on the same side of the string, or which are both on the upper side of the string. When they superimpose, the resultant diagram or the resultant wave will be shown in this string. So have a look. These are the two pulses, 1 and 2. They are moving in opposite direction. They are on the same string. And when they will superimpose, let's see what happens. This will try to move by an amplitude, let's say 2 units, and this will also will try to move up to 2 units. When these peaks will overlap, the displacement will be 4 units, and so on. Just look at that. At this point and at this point, these two waves interfere and a huge peak is formed. If at this point at this point there's just single disturbance, which is because of this wave, so the whole string follows that. And at this point again, but when the disturbance superimpose each other, the string has to listen both of them. This says 2 units up, this says 2 units up, so string moves 4 unit up. You can have a look once again, have a clear look. In this animation, we'll see how waves are being reflected if the end is fixed or if the end is free. Okay, so the black end is fixed and this white end is free, and these are the two pulses which are sent. You will see that uh, the wave which is reflected from a fixed end will have a phase difference of pi. This peak will convert it to valley. This peak will be converted to valley, whereas when a wave is reflected back from a free end, the peak will remain peak. Okay, let's have a look. Just see, they are about to get reflected. Yeah, so after reflection from a fixed end, the peak becomes valley, and from a free end, the valley, oh, the peak remains the peak. Okay, there's no change in phase from free end, there's a change of phase of pi from fixed end. Okay, you once again can have a look at that. They reflected phase change of pi, no phase change.